Okay, so here's a hydrogen NMR video going through a couple more slightly advanced examples. So in this first one I've got ethanol. Let's have a look what the graph of that would appear to be. So first of all, let's label our different environments. So these three hydrogens here I'm going to label environment A because they're identical. These we'll call environment B, and the OH we'll call environment C. Now, there's an extra rule to remember if you've got a hydrogen attached to an oxygen. This is identical if you have a hydrogen attached to a nitrogen. So although I'm using OH in this example, exactly the same thing would be true if you had an NH. So OHs and NHs kind of work the same in that way. And the rule is this: OHs or NHs do not cause splitting, and they do not get split. You can kind of think of this oxygen as acting like a roadblock for splitting. You can't split past it, and the same for a nitrogen. So in terms of the splitting we'd have here, well, my environment A has two adjacent hydrogens, so that would be split into a triplet. My environment B, well, you might say it's got three adjacent hydrogens that side and one adjacent on the OH. But remember, OHs and NHs do not cause splitting. So when we're thinking about splitting, ignore the OHs or the NHs. So I would just say I have three adjacent, and so that will be a quartet. And as OHs don't cause splitting or get split, they are always singlets. That's a nice, easy way of figuring out which peak is the OH or NH. If you've only got one singlet, it's the OH or the NH. In terms of my integration trace or relative peak area, that is the number of hydrogens in the environment. So environment A, I have three hydrogens, so they will have a relative peak area of 3. Environment B, I have 2, and I've just got one OH. And then in terms of my chemical shift, if I bring up my trusty data sheet, environment A is a H to C to C. And so you can see on the data sheet, that's somewhere between 0.5 and 2. 0.5 to 2. Environment B is a H to C to O. Now, H to C to O is between 3 and 4 there. So I'm just literally playing Snapsies on my data sheet. What does it look like? So 3 to 4. Now, OH is a tricky one. OHs and NHs, if you look on your data sheet, they're this strip across the top. So they can appear anywhere. So we're just going to put, I guess, a question mark. It could be anywhere on our graph. So let's go through that then. From 3 to 4, we have a fairly small quartet. Remember, the relative peak areas for the peaks are 1 to 3 to 3 to 1. For environment A, we have a fairly large triplet. And the peak areas there are 1 to 2 to 1. Let's just write our relative peak areas above. And then somewhere, I don't know, there we go, we'll have a singlet with a relative peak area of 1. On to our second example of something else to watch out for. Remember, identical hydrogens don't split each other. So this hydrogen here will not split that hydrogen there because they're both identical. Okay, so bear that in mind. Let's have a look at our example here. So again, I'm going to identify my environments. Now, as we have some symmetry down the middle here, these will all be environment A. And then these two hydrogens in the middle will both be environment B. Now, thinking about their splitting then, we have here environment A has one adjacent hydrogen, so they will be a doublet. And for environment B, you might say, well, we have 3 adjacent on one side and 1 adjacent on the other. But remember, identical hydrogens do not split each other. So if I'm looking at this hydrogen here, it will not get split by that hydrogen because these two hydrogens are identical. So this hydrogen here has 3 adjacent and so will get split into a quartet. The relative peak areas, you might be tempted to say, well, we've got 6 A's and 2 B's. But remember, we always use the simplest whole number ratio. So actually, it'll be a 3-to-1 ratio. And where do they crop up? We have a H to C to C. So on the data sheet, that was 0.5 to 2. And a H to C to BR. Again, if we look in our data sheet, we can see that's between 3 and 4. So 3 to 4. So what will that look like? Between 3 and 4, we'll have a very small quartet. And between 0.5 and 2, we'll have a fairly large doublet. Okay.